Hello and welcome to Ymt218 Object-Oriented Programming. So in this session we will just discuss the first part of Chapter 9, Dictionaries and Sets. We will speak just a brief introduction about dictionaries and how we created them, how we used them, and we will leave the rest of the chapter for other sessions. So we will just be discussing dictionaries, as I said. Sets and serializing objects will be left to next sessions. For this session, as I said, we are just discussing dictionaries and their elementary operations and how we create them, how we manipulate and use them. First of all, dictionary is a collection of objects or elements or data elements. So what we are speaking about here is a collection. It can be a sequence, and I will say why. But this collection has a unique identification tag, or you can say, or identification process. We have two connected elements or two connected components in this dictionary. The first one is the key, and this key is must be of immutable object type. That means it could be of any type actually that is immutable. You remember the immutable types of data that we took. Literals, for example, any literal thing that we have, it could be an integer, it could be a float, it could be a string literal, or it could be also of tuples. So could be also tuple. So one of these can be the key. Okay, then we have a column, and then after this column there is a value connected to the key. So we define the key, then we need to define a value that is identified by the key. So in this case we need to specify what is connected to this key. You may think of it as a key value pair. You can replace the key by maybe the identification number, the value by the name maybe, or you can change the key value to maybe name and phone number. It could be for multiple names and phone numbers. And here in this case we are doing something we call mapping a value to a key. Okay, so we map a certain value to a key that's connected to it. So how do we create a dictionary? The standard way for creating a dictionary in Python is providing the key value pair here, key, colon, value. The key, we set the rules for creating the key. It should be of immutable. That means something from the immutable types we know. It could be an integer, float, string, direct literals. Okay, or it could be a tuple. So in that case, it will be a key, a valid key. And then we have a value. The value can be of any type, literally any type, any. Okay. Then, if we are going to have other key value pairs, we separate them by commas. What we did, similar to what we did in lists and tuples, and then those will be encapsulated or enclosed inside braces, and that's our dictionary. That's how we create it. Okay, so look at this example. If we are speaking about ULP courses, I just put some because I don't want to list all of them here. Let's say I added Ymt218 object-oriented OOP, Ymt220 economics, and then Ymt114 principles of software engineering. And then I printed the whole dictionary. It will be displayed exactly similar to lists. It will be displayed the way it is. Okay. But one thing I have to tell you, I said I will say why it is not a sequence. First of all, usually we don't get the same sequence we provided. That's not the case. Currently it came to us exactly same. Well, it's not usually the case. You may create a dictionary in Python, then you print it out, and the sequence here will not be the same as here. This is number one. Number two, we do not have a numeric indexing. We can't use a numeric indexing to get the values from the dictionary or from a dictionary in Python. We need to use the key in order for us to get the value, and that's why it's not exactly indexed. It's not indexed. We use a key. We don't use an index, a numeric index, and that's why it's not a sequence. Okay. All right. We explain about the value, the key, the keys, and the values. Okay. How can we retrieve a value from a dictionary? We use the key. So the identifier, as I said earlier, is the key, and using this key we can access to the value. So how do we do it? We can use this form, dictionary name, and then brackets key. For example, here we have the dictionary's name, ULP courses. So we can put ULP courses, then we provide a key, any key. Well, you have 1, 2, 3 keys here and 3 values. Provide any of these keys the way they are. Pay attention that Python is a case sensitive, similar to most of programming languages. So if you provide this one in the lowercase letters, then it will give you an error, and we will see how in a while. So the basic idea is like you have to know for sure whether this key is available in your dictionary or not. And it's a good practice actually to inspect before we try to retrieve any value. So now look at this. I will show you the examples, then we speak about the exceptions or the key error. Now look, for example, I try to print the ULP courses. I try to print or try to retrieve Ymt218. I know that this one is available because I typed it myself and I know it's available in the dictionary. It will return to me the value of it, just the value the way it is. Okay. Now if I try to print something which is not available in the dictionary, what will happen? We will get the traceback function or whatever the traceback call, and we will end up with an exception raised. And this is a key error. Why? Because we provided a key which is not available in the dictionary. And in this case, in order for us to solve this problem, if you're not quite sure if your key is available in the dictionary or not, it's a common practice. It's good actually to start with checking or inspecting if the key is available in the dictionary or not. So we can use in or not in to inspect if the key is available in the dictionary or not. So we can do like this: if Ymt218 in ULP courses printed at. So in that case we will not end up having the traceback call and all that exception problem. You can handle this exception, but this is an easier way to deal with it. You can create try and except if you want to do a professional way of dealing with such a key error exception. Okay. Imagine we need to add elements to an existing dictionary. Now we have ULP courses, for example. How can we add a new dictionary? We use a key. So we say ULP courses or dictionary's name. Then we provide a key, the new key, and we say equals to a new value. So we have key value pair to be added to the dictionary. In that case, key value new element, which is a key value pair, will be added to the dictionary, and then we can print and see it will come out. It's not necessarily that we have it at the end of the dictionary. It may not. As I said, sometimes it will come to you at the end. Others it will just maybe shuffle them up, because it's not exactly a sequence that we are creating. It's a dictionary and doesn't care about the sequence. It identifies the values by their own keys, no matter where they are. Okay. Now, by the way, before I forget, if the key is available, now if I try to, let's say, add an element add a value to a key which is already available in the dictionary, what will happen? It will override the previous value that is paired or mapped to the key that you are trying to assign the value to. So let's say, for example, we have Ymt218 OOP. For some reason, I say, okay, ULP courses brackets Ymt218 equals this one. When I say, for example, here, let's say I change OOP to algorithm and programming, whatever it is, just a name of a course. What will happen? Simply, this key value pair will change, and the output or the outcome in this dictionary will be the same key will remain. We can't change the key in this case, but what will happen? The value attached or the value mapped to the key will change, will be updated. Okay. So in that case, you need to pay attention to what you are assigning, because you may override, some values available in your own dictionary. Okay. Imagine you want to delete an element from a dictionary. You use the delete function del. So del will allow you to delete an element based on the key. So you can use the key to specify an element to be deleted. And in this case, you will be able to delete that element if it is available, if the key value is available. If it is not, if you are providing a key that doesn't have a value, it's not available as an element, or it's not exactly a key value pair in your dictionary, then what will happen is a key value error again. So it's a good practice to use the in function. So try to see if it is available in your dictionary before you delete it. If it's not available, then you don't have to delete anything. There's nothing you will be able to delete anyway if you are looking for deleting something which is not available. So look at this. We added 112. Imagine I want to delete it. So I use del ULP courses, then I provide the key. It will delete the key value pair in my dictionary. So this is the idea. Now here's the idea. Look, when we print it again, when we try to reprint the whole thing again, we will find our key value pair gone. That's an element that we have just deleted. So we are interested in deleting it, and we just delete it from our dictionary. If we would like to check the number of elements available in our dictionary, we can use the len function. This is the length, so it's abbreviated to len, and we can use it for obtaining the number of elements. Now we say about the number of elements means the number of key value pairs, not key separate, value separate. Key value pair is connected, so any element in a dictionary is exactly determined by the combination or the pairing between a key and a value. That's one element, separated by one comma or a comma. That's an element by itself. So the combination of key value is an element, or a dictionary's element. Okay, so in that case, we can count based on those, and we can obtain the total number of elements available in the dictionary. Now think about it. Look at this. So if I print the number of elements in ULP courses, the last action we took here, we deleted one element. So we have 1, 2, 3. So this is the idea. We have 3 elements, and based on that, we will just get 3. One more thing. Now, the key value pair can be of any type. What does it mean? I don't have to have like integer for integer, float for float, or whatever, string for string. No, that means any immutable type can be a key. Okay, can be a key. So in one dictionary, I can have multiple key types. Of course, they have to be immutable, but multiple types, more than one type. Okay, and I may have multiple values. So I don't have. It's not necessarily that I have same rhythm of values, integers or floating point or strings. No, it's not necessarily. Okay, so look at this. Think about this. For example, we have another mixed keys. I just mixed the keys here, but still I also changed the values. Now look, this is also immutable. Why? Any literal value is immutable in programming language, so this one will not be changed. It's just literal, and this is usual. I mean, this is normal in our programming, because it's literal value. We cannot change it. If you assign it to any variable, then you can change that variable. Now let's say this is my key and assign a name to it. So key value pair here, I have a string which is mapped to a key of integer type. Let's say the second type, or the second element, is a string assigned to a number, integer value. The third element, that is a tuple, and it's mapping a string. And that's possible. That's totally possible. You may tell me, what kind of applications do we have for this? Well, I'm not sure. You may have. but I'm just giving you an example, simple example, so you see how these things can be mixed up and they will just work with no problem at all in this case. You can print them and get the output here. Okay, how can we create an empty dictionary? We can use two ways. The first one is just by assigning the braces. So let's say we give a dictionary's name equals to braces, empty braces. So these curly braces will create for you an empty dictionary with nothing. Or you can use, alternatively, you can use dict. Dict as a built-in function that allows you to create a dictionary, similar to list, okay, or similar to tuple. In that case, you can use these built-in functions to do the process instead of providing these symbols. Well, you can also iterate using a for loop, similar to list, tuples, and strings over all elements in the dictionary. How? You can use the key to retrieve all keys, or you can use the key inside the dictionary to retrieve the values. That's possible. So we can do any of these actions to retrieve the values or to retrieve the keys. Now look at this example. For example, I create a dictionary, empty. It has nothing. I can add values to it. Now imagine that I'm speaking about results. Let's say we have 3 exam results, and then I add the number of the student as a key, and I add the 3 exam results as a list. So the value would be of type list. So it's a list with 3 elements, 3 exams, let's say, or 3 quizzes, and then we have the key, maybe the enrollment number of a student. So this is possible, okay? Let's say I want to create it by another way, not by just stating or typing these braces. I would like to create the result or maybe any other dictionary by using dict as a built-in function. That's possible. You'll just get an empty dictionary. You can add things to it, similar to what we did earlier. Let's say you want to iterate over the elements of a dictionary. You can get the keys from a dictionary, and then you can either display them, or maybe you can display the values based on these keys inside the dictionary. So here I displayed the keys, and I put the column, and also I displayed the values so that you see how you can retrieve the key and the value from a dictionary using for loop. This is possible. Or you can provide maybe one new line after each element. It's up to you. I mean, this is a customization process. You decide what you are going to do, I mean, in terms of the printing. This is the end of the session. I hope you guys enjoyed it, and I hope you will benefit from it. We are just at the beginning of this chapter, so we haven't taken much yet. I'll create other sessions soon enough. Until then, have a good time. Goodbye.